Hello everyone. I hope you are doing good. You know about the last class we talked about the SDLC life cycles and gave an example of a pen, like how it works. So today we are going to dive more deep into it. So I think we should get started. So all right. Today we focus on understanding the relationship between different components in a system using the example of a pen. Let's start. um, let's start with the cap of a pen. Okay, so the cap. So suppose this is the cap of a pen. Okay, do you know if this cap depends on any other parts? Let me tell you, the cap is a small component made from plastic and don't rely on any other part. So we can say that it's independent. Okay. Now let's talk about pen's body. Pen body. When we talk about pen's body, we can see that there is level in it and it involves not only the body but also the in. Also the in body and the level. These all have dependency on each other because they are all connected to create a single final product. So when we talk about the development environment, we usually break it down into three phases. They are developer, developer tester, um, tester, and the status phase. Each phase deals with different tasks and dependencies. For example, when we talk about the body of the pen, we see that the ink is developed first, followed by the body and the level. Now let's look look at how these components work together in the development process. We can say that the ink is the pen module. In the module, followed by the body, which is the child module of the ink. Okay, And the third one is level. It's a salesman. It's important to remember the terminology. Pan module usually refers to component which is developed first, and the charge module refers to the component that comes later. Okay? Then in the system, each component, whether it's the cap or the body or the ink, they go through a development and testing cycle. For example, for the, then here we can see that the development is the development of a cat takes usually 1 week to develop, and the tester spends another week to verify and test it. This process is called sprint. It's called sprint, which usually lasts for 2 weeks. Okay, and now let us discuss about the definition of a sprint. A sprint is a time box period, which means all the team members, like the testers, the developers, and others, work together to deliver a set of prioritized features or user stories. The goal during this time is to identify the defects and ensure that the product meets required standards, and complete the development of the feature by the end of the sprint, like this one. Okay. We talked about the user stories in the last class. So each user story follows a specific form. It's often called the Gaussian form or the form. It is like when given the precondition, and after giving the precondition and when the action is applied, then we get the expected outcome. These structures helps create clear and understandable user stories, especially for the non-technical stakeholders. So we can see that mm, here's the body screen, here is the ballpoint screen. Each of them went through the testing phases. Some took 4 days, some took 6 days, and after that, after testing, we can see that it is perfectly working. So prepare the business requirement specification BRS. Business analysts use this format, which is the Gherkin format. Uh, it is essential for preparing a product backlog. The product backlog contains a list of all the user stories, each with acceptance criteria that defines product requirement. And as the development progresses, each feature or component undergoes different level of testing. Like when the cat was tested for the first sprint, the main focus during the second sprint is pen body, like I thought before. It ensures that each component fits and works finely as expected. When the developers integrate different components like the body and the cap, the testers verify that they should work together. Testing can involve unit testing. This type of testing ensures that the product are working correctly and they perform as expected before integrating with the other. So finally, when the components are integrated like this, all these are together, then like the pen, cap, and the body, the full pen is assembled and tested as a whole. This comprehensive testing ensures the pen works perfectly and all the modules like the parents and childs are functioning correctly. So in summary, the development process involves creating components like the cap, body, in testing them individually and then integrating them. The sprint cycle helps organize this process into a set time frame, and testing is done at this stage to ensure everything meets the requirement. Now, we talked about the unit testing. Unit testing is performed by the developer. When the tester runs the same test, it's called component testing, and it's done by testers. Mm, testing. Unit testing is done by developers, while the component testing is the same test, but it's conducted by the testers. Component testing takes the smaller units of the product, also verifies the interaction between different components. Takes the smaller product. Now, when all the parts are fitted together, like Mhm. When all the process fitted together and tested again, it's called regression testing. Regression testing. For instance, in sprint 3, here, this one, we were integrating parts, adjusting one component to fit with other, and then retesting everything. Regression testing is when the same test is repeated to ensure new changes haven't affected existing functionality. So it happens again and again, repeated process. The next one is called integration testing. The next one is called integration testing. It focuses on verifying the interaction between the components when they are integrated together. This is when you connect all the parts like the cap, body, and the ball joint and check how they interact. Integration testing is performed by testers. By testers. To clarify the difference between the regression and the integration testing, regression testing involves running the same test again to see if new changes are broken into. For example, after integrating the ball point with the cap and the body, regression testing ensures nothing has been disrupted in the pen's functionality. So it checks the function. On the other hand, the integration testing is focused on how the components work together once they are integrated. So it checks how the components work together. In the development process, after the product is integrated and ready for the next phase, it enters the system integration testing or SIT environment. This is where all the components of the pen are put together. After this, it goes to SIT environment. Here, all the components of the pen are put together and product undergoes testing before moving to user acceptance testing or UAT, which we discussed in the previous class. Now let's imagine a scenario where the development and testing takes 6 weeks. The first 2 weeks are dedicated to developing and testing the product. Once this phase is done, just um, Once this phase is done, the next 2 months are focused on system integration testing and acceptance testing. During the system integration phase, we ensure everything functions properly before moving down to the production. If we have a total 4 months of product release, the first 2 months focuses on development testing. So focuses on development, it focuses on development and testing. After that, um, during this time, full regression testing is performed to verify that the major functionalities are working as expected before the product is released. Let's say the product is in heat environment for 2 months. Sorry, 1 month. 1 month. In that case, the testing time is limited, so not all cases can be executed. This is where automation testing comes into play. This is where automation testing. If there is not enough time to run all the tests manually, automation scripts are used to speed up the testing process, particularly where there are thousands of test cases to cover. Once the product passes integration testing and user acceptance testing is ready for release. At this point, the tester's main goal is to identify any defects. Identify any defects. If no defects are found, it means the product is ready for deployment. Now, regarding the BRS, in large organizations, BRS is typically prepared by the business analyst. However, in smaller companies, the project manager may take into his responsibility due to budget constraints. It contains functional and technical requirements. In some cases, companies may include additional documents like system requirements specifications or functional requirement documents. Functional requirement specification describe the product function. There is FRS. For example, a fence cap must be fitted into its body properly and the ball point should rise smoothly. So it depends on the behavior of the product. Technical requirement specification, on the other hand, cover the technical aspects of the product, such as materials, the depends on the material. For example, the specification will detail the type of plastic used for the paint body or the temperature required to mold it. So the testing is done at various stages, like unit testing by developers, component testing and integration testing by testers, regression testing to ensure no changes do not affect the product's functionality. Once the product has passed all the steps, it's moved to user expected testing before going to the market. Now we'll talk about the tool called Confluence. Um, it's called Confluence. You can use this tool to access different documents such as the S, F, etc. These are all part of your testing journey. So let me show you. Here is a diagram of a software called Confluence. Here you can use different options like options, and each one will open a document related to it. For example, when you click on the option BRD, it will take you to the detailed version of the user story we discussed before. So a basic user story can be as a user, I want to make a friend that I can help you. This is just a basic form of the story. The BRS document elaborates it and provides more detail and follows a structured form. So let me tell you what Confluence is exactly. Confluence is a software testing tool. It is a mm, software testing tool. It provides a platform to manage testing activities like cases, defect reports, and requirements. It's like an organizational hub for all the documents related to software testing. It helps us to stay organized and it's also great for collaboration. You will use this software in your different assignments and projects. So the basic workflow is you will open Confluence, navigate to the menu, click on them, and you will be directed to the detailed document. This is the part where you will find the things like acceptance criteria, test strategies, even the scenarios. So let me draw here. Okay. Okay. So, what happens next in Confluence? After you click one of the menu options, you will be taken to the corresponding document. You will find after clicking into section like BRS, you will find the options like business requirement, acceptance criteria, case scenario. And each section will give you the detailed explanation of what's required. For example, when you open the acceptance criteria, you will find a set of conditions that must be true for the product before the product is complete. Okay, now um, like here, there will be like BRD defect, then test strategy. It will open another separate option. Like this, you will get different options for different selection. Now let's discuss SRS. SRS. Uh, it usually has three main parts. It has functional, um, um, then the non-functional, then the technical requirement. The functional requirement describes what the product must do. For example, a pen must write smoothly, it should not leak, etc. Then the non-functional requirements, this focuses on the broader goals and objectives, like for a pen to be what is required for a pen to be durable, the number of colors. In such for softwares, non-functional requirements may involve scalability or the ability to handle many users at once. These define the business goals and product capacity to perform under various conditions. Now, for the technical requirements, this focuses on the tools, technology, resources used to develop the product. Like for software, it can be programming language, framework, and servers, which it needs to be built and run. Now, let's look at the example for a non-functional. You know about Amazon, right? Mhm. Mhm. Amazon. It is a well-known online platform. Non-functional requirements for Amazon would include things like how many um, users can enter the site at the same time without performance issue. So it's like users number, Then how many countries can be serviced? How many countries can be the service be operated from? Then what is the uptime of the platform? Okay. These requirements don't concern the features of the product, but focuses on its capabilities and business goals. For instance, can Amazon handle a million of users at once? Can it run smoothly at different part of the world? Now back to the functional requirement. Um, we know a functional requirement of the product like pen would include if it writes well, is it strong enough, or if it has multiple colors for user. These are the practical features user need to interact with it clearly, ensuring the product serves its intended purpose effectively. Now, the combination of functional, non-functional, like all of these things, form the complete picture of what the product must achieve. Functional requirement about what the product does, non-functional are about how it fits into larger business, and technical requirements are used as a tool and it needs to be made into a reality. So you will be using Confluence to explore and manage these requirements as you work through your testing project. As you continue to familiarize with the platform, you will be more comfortable navigating to different options, understanding how the documents are linked together. Now let's discuss the duration of which person can use a particular service and how long they can remain logged into their account. The important when considering the functional, non-functional, and technical aspect of the SRS. Now let's move on to them. For example, let me show you. Mm, um, so, mm, okay. There is a document from like called Authentic. It's an e-commerce platform. Um, this document is like a user manual focused on primarily the product's functional aspects rather than the non-functional. It helps to identify and explain product features through visuals. In the case of a pen, for instance, it would outline why the pen is created and what its function really are and what materials are used. The document will typically involve an overview of the product. Like in OpenCart, it's the front content. These are the front content. Here what we see, they show what we see as a user. They are called the graphics user interface. This is essentially the front end of the product. For instance, when you log into Amazon, the interface you interact with the front end of the application. Now, this document is created by business analyst. It's created by business analyst who gathers information and knowledge from experts as visuals and ensures the document is approved by the business stakeholders before being uploaded to Confluence. Now, let's explore the concept of software testing. Okay. Explore mm, software testing. Imagine the pen is a software product. So it has pen, body, and the ballpoint. Okay. Similarly, a software is made up of different components or modules. We can say the pen is a collection of these parts, just as the software is a collection of different items or programs. Each program can be thought of a module within a large software structure. For example, an application like MS Word or like Microsoft Word. Each option or features like file, home, insert can be considered parent module. File, home, they are the parent module. And the subfolders within them like save option are child module. Moving on, let's talk about software. First, we have application software, which includes programs you download on your phone or computer, such as Instagram, such as Instagram, WhatsApp. These are known as application software. You can install them on devices like computers, tablets, or smartphones. Next, there is system software. System software, and they are the software which operates in the background, like when you plug in a pen drive, um, when you set up an operating system like Windows. That's the system software. Operating system like Windows and Linux are the example of operating system software, as they manage the hardware and provide essential service to application software. Then we have the utility software. The utility software provides additional functionality like the into hiring of the software backup tool. As testers, we typically do not work with system software. Instead, we focus on application software. There are also programming software. They are like Java, C++, etc. They are used to write and debug code. They often features debugger and compilers to help develop. As testers, we work primarily with the application software, which includes application, mobile app, desktop application. Now, there are many applications like web application. These are the things we access through browser. For example, if you're using Facebook from www.facebook.com, it's a web application. The software runs on a web server and you access it through your browser. Then we have the desktop application. These are installed on your computer like Microsoft Word, Photoshop, etc. They don't require internet connection. Then we have mobile application. This can be downloaded on your phone or tablet, like Facebook app, and these are the different types of applications. Okay? Now, most of QA testers focuses on web applications because they are accessible focus on web application because they can be accessed to browser. For example, Facebook can be used through a browser or downloaded as a. Finally, let's talk about the domains in the context of web application. Domain. A domain is um, essentially a place where the website holds their um, a domain is essentially a place where the website holds their server. Like there can be different kind of domain. For example, there can be healthcare domain, then social media, e-commerce, finance. The healthcare domains can include clinical website, medical software, etc. The social media domain is where the testers can work with Facebook, Instagram. The e-commerce domain can help working on Amazon, eBay, Walmart, etc. The finance domain can be used for stock trading platforms and other services. Each of the domains presents unique testing from opportunities for QA professionals. By understanding the domain, you can better understand the kind of software you will be working and the specific requirements. Testers can apply to work in any of these domains based on their intent and expertise. Now let's look at SDLC. SDLC. It is essentially what we are learning from the last class. Can you remember the steps like before we discuss things? Yes, let's break it down. The first step was the plan requirement specification. Based on this, the product owner and the product owner created the product backlog. From there, the business analyst prepared the business requirement specification or BR. After this, we began planning. So before we even got into the planning, we started with the requirement analysis. So start with, once the POS is ready, the architect prepares the design document, and after the design document is completed, the developers begin the actual build of the product. Right? For that, design. There were multiple stages a product must go through before reaching the point. Do you recall about the initial stage? It's called development environment. In this phase, parts are tested separately. Once the product moves from the development environment, it goes to the seed environment, which is system integration testing. Then it moves to pre-production, pre-production. After that, it goes to production. This entire process is called the SDLC lifecycle. Okay. This whole process is SDLC. Now let's talk about software testing. Software testing. Software testing. Software testing is an activity to detect and identify the defects of the software, which is called the bug. The primary reason we do software testing is to find and defect this before the product reaches to the customer. Okay. So our goal is to uh, detect those bugs. The term bug is just another name of a defect, but there's another meaning of the bug like the insect. These are the insects of the software system. So what is the of objective of the software system? Objective The objectives are The primary objective is to deliver free, defect-free, and high-quality product. High quality to the client because the client is paying money, so they should receive the quality product. For example, if a business if a business has given me 1 billion to build a software and I request another million 3 months later, it will give a bad impression to them. Proper planning should be kept as budgets are essential. So our goal is to do high quality and bug free product. Another key point is customer satisfaction. If a product meets another user requirements and acceptance criteria, it is considered successful. That's how you know you have met the client's expectation. Let's say you have ordered a dairy product from a farm. They're supposed to deliver it fresh within 2 hours, but you receive them after a whole day. Do you think the farm delivered the product as expected? No, it didn't meet the quality expectations. So meeting the deadline and delivering on time is essential. So deadline is important. Then we talk about maintenance. Maintenance is also important in software. If a feature on Facebook and Amazon is not working, the maintenance team needs to ensure users can still use an alternative while the issue is being fixed. The maintenance team monitors, fixes the issues, and they ensure the software continues to function properly for user. If user face difficulty, they report it to the maintenance team. Now let's explore the difference between error, failure, and bug. The error is when human makes a mistake. For instance, entering into an incorrect email or password. Um, so the error is in, in the failure is when user experience a problem despite entering the correct information. Like unable to log in. And the bug is where a tester spots the issue in the system, such as the login button if it doesn't work when the current details are required. Suppose a user mistakes their email or password. That's an error. When they enter correct information and still can log in, so that's a defect or bug. When the tester observes the malfunction is also considered a bug or defect. Now, let's talk about Scrum. In agile development, the team of developers, testers, business analysts are referred to as a Scrum team. So, developers, testers, business analysts, architects, they are all called Scrum team. The Scrum Master plays an essential role in facilitating the Scrum process. They are not developers but acts as task planner and advisors and organizers. They schedule meetings, track progress, ensures smooth communication between all the members. So, purpose, so this is the prompt and this is the Scrum Master. So, what's the difference between a project manager and Scrum Master? A project manager oversees all activities related to the overall project and product delivery, whereas the Scrum Master specifically focuses on organizing and tracking activities related to the sprint. Okay, now let's talk about bugs. Why do bugs happen? Bugs can occur through different reasons like miscommunication, then complexity, then error during program. Miscommunication is where developers and testers might not communicate clearly, leading to misunderstanding. And the complexity is complex systems are more prone to bugs because they have the intricate design and multiple interdependent components. Then programming errors can occur when developers make a mistakes like a typo during leveling and like then in agile development, requirement can change at any point. For example, after a developer finishes a future business stakeholder might ask for change. If the requirement changes frequently, it can introduce new bugs. Now we dive into the deep of software development life cycle. SDLC. It is the backbone of any successful software project, and understanding it is crucial for ensuring that everything is delivered on time, on budget, and with quality. Time, budget, and quality. Now about what we think about SDLC. We have several stages like requirement gathering, design, development stages. But today we are focusing on the requirement analysis. Requirement, um, Then we will discuss about refinement. Let's start with requirement gathering. This is where all begins. The business analyst plays a key role here. They are the one mm, business. mm, They are the one who work with the stakeholders, including the product owner and project manager, and capture business requirement. Once he collects the business requirement, he prepares the documents for BRS. He prepares BRS. It outlines exactly what the business wants to achieve. It includes acceptance criteria, user stories, and schema. Acceptance criteria, user stories, and schema. Essentially, this is the contract between the business and the development team. Everyone has to be on the same page to work and in developing the product. For example, if we are building a login page, the BRS will specify that the login button must be at like this certain size or error message should appear. There should be a message. If the user enters invalid credential, once the BF prepares the BRS, the next step is presented to the product owner and the project manager. They review the document to ensure that it meets business goals and is realistic in terms of implementation. They are the ones who give the green light for the project to move forward. So it goes to product owner, then product. Mhm. But what happens after that? Well, once the product owner and project manager give their approval, the BA job is not through, it's not done yet. Now he has to work with the Scrum Master to get everyone in the same page, okay? So that they can work together. Now, after going to the Scrum Master, we begin the pre-refinement section. Now the pre-refinement section. Hmm. The VA reaches out to the Scrum Master, who is the facilitator of the team, to for the next step. This is where the team, developers, testers, architects, and other team members get together to review the BRS and discuss potential changes. In this session, the Scrum Master schedules a meeting. Okay? So, mm, in this process, schedules a meeting. They send out invoice which includes everyone like developer, tester, architect, even the product owner. Also the PA. Suppose they are in a meeting for users to one, user to one. The Scrum Master sends out invite and includes all necessary details and the etc. Then all team members come together with their thoughts, feedback, and ideas. In this stage is where the BRS document really evolves. Let's say the BRS specifies that a login button should be a certain size. Now the developer or testers might suggest that the button should be a little bigger or it should change color when it is clicked on, or perhaps the creator said um, when the user enters incorrect information, the system should give them a suggestion for better perspective. These feedbacks are really important. You understand? Is during this session, the whole team can bring their expertise into the process and improve the requirement. This makes the BRS smarter. All of this makes the BRS smarter. So, what is a smart BRS? Well, smart BRS stands for different things. Yeah, F, M, A, R, D. The S stands for specific. The M is for measure. The A is for achiever. The R is for relevant. And the T is for bound. So for S, the requirement needs to be very clear and specific. For example, instead of saying the login button should be big, we should specify that the login button should be 150 pixel wide or 50 pixels or something like that. And for measurable, we need to know when a requirement is fulfilled. Like if it says a button should be clickable, we need to define that it works on all devices. Achievable means we need to build something that within the time frame and the budget. For example, suggesting a highly durable but expensive material might not be achievable. For R, which is relevant, it must align with the overall goals of the project. For example, a login for an e-commerce platform should focus on speed and ease of use, not aesthetic features. And for time bound, it is feasible to complete the project within the given timeline. Now we will discuss BRS refinement. The refinement. As a result of this refinement session, the BRS will be corrected and updated. This process involves a lot of collaboration and feedback. If the developer and testers point out the issue, say with the login button size or functionality, the BRS documents is updated to reflect this suggestion. The feedback loop is critical here. Feedback loop. For example, if the developer says here, I can make this button durable enough with the current design, the team might discuss the alternatives. Perhaps they can use a different material to redesign and to make it more durable. This collaboration makes the BRS a living document because it's always evolving until it's perfectly. Once the BRS is excuse me, once the BRS is smart and ready, we move into the refinement session. We use tools like time boxing, like time boxing, to determine how much time each step we take and ensure that every requirement is considered. Used for schedule tasks. For example, the developer might say, I need 5 days to complete the task. The tester may need 3 days to test it, and that database administrator might need an additional 2 days. So 5 plus 3 plus 3. Total 10 days. This time estimates to help everyone know what to expect and how to plan. The team gets to understand their role and how much effort will go into each part of the project. So after wrapping up this phase, the team moved forward with the sprint planning. Sprint plan. Here they start assigning tasks to the upcoming sprint and prioritize features. Assign tasks and prioritize features. But we'll discuss sprint planning in the next session. So for now, I hope I'm able to give you a proper understanding how the SDLC lifecycle works, how the sprint works. And if you have any question, you can ask me, then we can. Okay? Thank you for your time. Hope to see you in the next class.